So in this problem, we're just trying to figure out what reagents we need to affect this conversion here. So we start out with an amine and a carboxylic acid tethered together in a molecule, and we're basically just doing an intramolecular reaction because everything's happening within this one molecule. And then what we're getting out of this is a cyclic amide, which we know is a lactam. Now, we do know that by taking a carboxylic acid and amine, if you heat it to a high enough temperature, you can overcome the energetic barrier and get some amide formation. And it might even work a little better here because it's an intramolecular example. But that's really not very synthetically useful conditions because just by heating this, the yields would be pretty low. But we do have a couple of better methods that we could use. The first is through the DCC coupling reaction. Now what DCC does is by getting attached to this carboxylic acid oxygen, it turns this into a better leaving group than just a standard OH, but also through that process you lose this proton, so it's no longer a protic source, so that's not going to cause you any issues. So just by treating this with the reagent DCC, we can form the lactam. So that's sort of the one-step protocol. Now if you want to keep the reagents even a little more simple, we could do sort of a two-step procedure. We could start with our carboxylic acid. Then we could convert this to an acid chloride using thionyl chloride. Now from here, you can just do the cyclization because now we have our amine, which will react with the acid chloride. Now because you may not want to use an excess of amine like we would in an intermolecular example, it's probably a good idea to add an external base like pyridine here. So then that allows us to do this cyclization.